So see now, next numerical is a 4 microfarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply and it is connected to another uncharged 2 microfarad capacitor. How much electrostatic energy of the first capacitor is lost in the form of heat and electromagnetic radiation? Okay, so here, so previously it is like previous question only. Okay, see here, so initially they have given the 4 microfarad capacitor and it is connected to a 200 volt supply. Okay, so 200 volt supply and the capacitor value is 4 microfarad. Okay, and it is disconnected from the supply and it is connected to another uncharged. Okay, so another uncharged they have given. Okay, both are capacitor only. So initially this is 4 microfarad, another one is 2 microfarad. Okay, so we need to calculate the how much electrostatic energy of the first capacitor is lost, so in the form of heat and electromagnetic radiation. Okay, see here, so C1 value is 4 microfarad. Okay, it is charging by connecting a supply of 200 volt supply. Okay, so initial case, so energy is given by E1 is equal to half C V square. Okay, so initially I will take V1. Okay, so in second case they have not given, so V2, that's why V2 is equal to 0 here. Okay, so here I will mention Et is equal to half C1 V1 square. Okay, so here E1 is equal to half, so what is value of C1? So 4 into micro means 10 to the power of minus 6 into V1 square means, so 200 square. Okay, so E2 becomes half into 4 into 10 to the power of minus 6 into 200 square means it will becomes 40,000. Okay, so here, so 2 ones are 2 2s are, okay, sorry, this one is E1. So if you simplify this one, so finally you will got energy as, so here, so 4 2s are 8. Okay, so 80,000 you will get. Okay, so 80,000 into 10 to the power of minus 6, so energy is joule. Okay, so this is the initial case energy expression. Okay, so next second case, so the energy connection, see here the energy connection here, so E2 is equal to half C V square only. Okay, so next one, here there is no voltage here. Okay, they have not given a voltage, but here voltage becomes common. Okay, voltage is common. Okay, in both the cases voltage is common, and here the two capacitors are in parallel. Okay, so if two capacitors are parallel, so the formula becomes Cp into Vc square. Okay, here Ep is equal to half, so what is Cp value? It is C1 plus C2 into V square. Okay, so that is Vc square. Okay, so now, so call this as equation 1 here. Okay, now I need to calculate what is the Vc square. Okay, so we know that from the capacitance of the capacitor is given by C is equal to Q by V. Here we need to calculate V becomes Q divided by C. Okay, and here, so Vc becomes here total charge divided by total capacitance. Okay, here total charge by total capacitance. Okay, here, so Vc becomes, what is the total charge value? Total charge value is, so Q1 plus Q2. Okay, divided by total capacitance is C1 plus C2. Okay, so that is Vc is equal to, what is Q becomes? Q becomes C1 V1. Okay, Q is equal to CV, but here it will become C1 V1 plus C2 V2 divided by C1 plus C2. Okay, but what is the value of V2? So V2 value is 0. Okay, so that's why it will complete term, it will become 0, and Vc is equal to C1 V1 divided by C1 plus C2. Okay, here Vc is equal to, what is the value of C1? C1 is, so 4 into, and V1 is 200 divided by, so C1 plus C2. Okay, C1 plus C2, here it will becomes, so 4 plus 2. Okay, here if you simplify this one, so 4 2s are 800 divided by 4 plus 2, 6. Okay, so finally if you divide this one, you will get 133.3333 volt. Okay, so this is the VC value, so we got, but I need to calculate E2 value. So sorry, this one is E2. I need to calculate E2 value. Now substitute here. So E2 is equal to half into what is C1 plus C2. So C1 plus C2 means, so here 4 plus 2. Okay, so here 4 into 10 to the power of minus 6 plus 2 into 10 to the power of minus 6 into VC square. VC square means, so 133.3333 whole square. Okay, so finally if you simplify E2, so E2 value you will get as 5333.3 into 10 to the power of minus 6 joule. Okay, so this one is E2 value. Okay, but what I need to calculate? I need to calculate delta E value. Okay, so delta E value I need to calculate. So that's why it will become, so E1 minus E2. Okay, so what is E1 value? So E1 value is, so 80,000 into 10 to the power of minus 6 minus 5333.3 into 10 to the power of minus 6. Okay, so if you simplify, if you multiply, okay, so you will get 2666.7 into 10 to the power of minus 6 joule. Okay, so this is the required delta E value.